Hi, right, this is my version 2 crank system. There you are. This wheel is just for decoration, but basically if you space out these struts here, you can have a bigger wheel. So currently it's slightly bigger than this protective shroud here. Right, now the tensioning system is this. It did have a, I can't remember the correct name for it. It's like a coiled spring in the hinge, but it was way too strong. So I've taken it out, and you can see it just pulls the band around the drum. And I was thinking of a knob on the outside of the Gurdy case here, which altered the pull on this part, you see. I don't know if you need a spring at all, or whether it's engineered well enough that you just need like a threaded rod that goes in here through almost like a nut sticking out sideways, like a tensioner there. So I don't know if you want to think about that. The band that the pad is fixed to has a degree of sort of springiness in itself, which is why, you see there, which is why I don't quite know if you can get away without a spring, because the side of the Gurdy will be here. Using the dimensions of your standard digi-Gurdy, the width here, the centre of the crank now to this point here will bring you to exactly this edge here internally. And also, if you look, the height from here to this flat area here, and also this little tab here, you see, if we insert it, hang on, this one is being glued, see, you see it's designed to fit exactly. And as just to repeat, this distance from the center point to here is the same as the distance from there, center point there, to that inner edge there. So you would have this part sticking out through the deck, and this could be quite ornate. It could be laser etched with all sorts of patterns, okay, but you see it looks quite nice going around. And you would only see, you see I've even made an edge here for 3mm panel to butt up to, and the same there, so you would just see this part sticking out through the top of the deck. So that could be made quite elegant, and you wouldn't get your fingers trapped in it unless you really tried. Right, now eventually I agree we'd redesign the circuit board on the back here to match your layout of the keys, and these holes would match your key layout. For now, just for messing around researching, I'm using one of my existing designs. You can see I've filed the key slots, the micro switch holes a little to get these reed switches in. These are actually considered small by reed switch standards, and the ideal area to put your magnet over is not the center, it's actually this point here or this point here. So on all my keys, which will be 3D printed just for now, the magnet is going to come in over this point here. So I've measured that distance there, and I'm experimenting with different magnets. These are slightly too small. These are about 2mm in diameter, and they need to be within about 3mm or less of this point to reliably trigger them. These are a little too big, and I've got some 3mm diameter ones coming, which should actually be absolutely perfect. Right, this is the Dingley automatic, my test rig for reed switches. So my meter's set to beep. Here's one of the 2mm diameter magnets, and I don't know if you can see, but if I get within about 3 or 4mm, hear the beep, or there, but not the middle so much. You have to be a lot, well, it doesn't even work actually. So I'm trying to get a range of 5 or 6mm. I think that would probably be best to reliably activate it. So I'm going to get some, these are 2mm by 4 or 5. I'm going to go up to 3mm by 5, which should be quite a bit more powerful, and I think they'll be just about right. So if you bear with me, I think
this can be made to work really well, and there's no sideways crosstalk then between adjacent reed switches, or at least I hope.